Keep it up, come on. Keep going, keep going.
Okay, so now we have the data. So we've run the test. We've got the breath-by-breath data. The key thing that we have to do now is to be able to calculate the MAOD. So what you see on the images here, if you look at the image on the right, you can see a schematic which in essence shows you what the MAOD would look like. You've got the area which is the red section, and that reflects the oxygen cost during the exercise, and you've got the area which is the blue area, which represents the estimated anaerobic capacity. So at the very top, you can see, which moves across to the panel on the left, you can see that we've got an estimated VO2 cost, that is what the demand would have been at 120% VO2 max, and therefore the red zone represents the actual aerobic cost of doing the work, and you can see that the line never goes above that of VO2 max. So the blue area represents our anaerobic capacity. So that area in that curve is anaerobic capacity. You in essence subtract one area away from the other, and you'll be left then with the MAOD. Okay, so we see the same image again, but we're going to use this to explain a little bit about the issues of validity and reliability with the MAOD. The first thing to note is that one of the major limitations with this lies in the way in which we set the exercise intensity. To do this, we actually base the MAOD trial on a previous test. That would be a VO2 max trial and ideally a series of submaximal trials to establish the individual's economy. Now, the limitation lies in this because the assumption is made that there is a linear association between exercise intensity and VO2. Now, that assumption holds true for anything up to the lactate term point, or you may have heard this as the lactate threshold. Once we move beyond the lactate threshold, actually what we start to understand is that we lose linearity because we engender things like a slow component in VO2 once we move into the heavy and severe domains. And then once we move beyond VO2, that supramaximal exercise, the relationship between VO2 and exercise intensity, again, you've just got that ever expanding form of slow component. So in other words, we never get a steady state VO2 response. So the notion that the association between submaximal exercise intensities, which you can see on the graph as the red data points on the left panel, and exercise intensity being linear is perhaps slightly ill-conceived. The second limitation lies in the fact that we've got to actually estimate the VO2 max. Now, that in itself doesn't seem to be a major issue, but there are huge confounding issues in estimating VO2 max. There are numerous studies that have shown the fact that identifying VO2 max is limited by the way in which we classify a maximal effort. Do we use a plateau criteria? If we use a plateau criteria for VO2 max, what criteria do we use for it? What was the protocol that we used to get to VO2 max? Was it step-based? Was it ramp-based? Did we use a verification trial? Now, none of these actually were expanded upon in the original study by Medbo, but subsequent work in the literature has certainly demonstrated that we have fundamental issues with identifying VO2 max. We then come to the third issue, which really lies in terms of the actual exercise intensity that we prescribe. One of the things that is really understood is that the intensity that we do these trials at has to be set, and this is based upon the Medbo paper, anywhere between about 110 to 130% of VO2 max. And that really lies in the fact that we're trying to tap into the anaerobic substrate metabolism, but secondly, there is quite a bit of literature now that shows that as the intensity of the exercise increases, it has ramifications on the ability to get repeatability in those results, and it affects the ability of the individual to hold that exercise intensity. So making sure that you've got the right intensity of exercise is fundamental to ensuring that you've got valid and particularly reliable results. Further thing to consider when we're thinking about the reliability is the test-retest capability. And this is data from a study published by Doherty back in 2000. And using the limits of agreement data sets that you can see here, you can actually see that the MAOD actually has high variability in its repeatability. You've only got to look at the MAOD data set, which is on the left, and you can see this high variability. Now, why is that the case? Well, if you look at the limits of agreement graph on the left panel, so that's the one that's showing you the time to exhaustion, what you'll see is if you look up and down the y-axis, that gives you the 95% confidence intervals, and it just shows you the range in the mean of the differences. And it goes from around about 32 seconds in the positive to around about 32 seconds in the negative. So what that is saying is there is a plus or minus error of about 64 seconds in a test which has got a duration of ideally between 1.5 minutes and 2.5 minutes. So there's a huge variability in that. And then coupled with that, because the MAOD is a function of the exercise intensity and more importantly in this case the time, the MAOD itself also has high variability, as can be seen in the panel on the right.